Okay, here we have to solve this linear inequality, right? We have 6 minus 2/3 times, in brackets, 3x minus 12 is less than or equal to 2/5 times 10x plus 50. And the first thing I'm going to do here is get rid of these brackets by distributing the number in front to both terms, right? So what's going to happen is we're going to have negative 2/3 times 3x, right? So here the 3's will cancel, and so we'll have negative 2 times x remaining. And then negative 2/3 times negative 12, the negatives will cancel out, so we're going to get a positive number. And 2/3 times 12, you could think of it as 2 times 12, right? That's 24, then divided by 3, which is 8. On the right here, again, multiply the 2/5 to both terms. 2/5 times 10x, that's like 10 times 2, that's 20, divided by 5 is 4. So 4 times x. And 2/5 times 50, again, you can think of it as 2 times 50, that's 100, divided by 5 is 20. So again, now you can see we just have a linear inequality. Now we want to isolate x. So we have two terms with x, and we have a bunch of constants here. Now I'm going to move all the x's to the right side. Again, it doesn't matter which side you choose. I want to move to the right so that my x's will become positive, right? So I'm going to add 2x to both sides. I could also subtract 4x from both sides and move it to the left, right? But I want to avoid negative, so I'm going to do it this way. And what are we going to get here? Again, the negative 2x plus 2x, those cancel. And here I have 6 plus 8, so I just combined like terms to get me 14. On the right here, I have 4x plus 2x. Combine like terms, it gives me 6x. Now, again, I want to isolate x, so I'm going to subtract this 20, right? I'm adding 20 here, so I'm going to subtract this 20 to cancel it out. Subtract 20 from both sides. So on the left, I have 14 minus 20, that's negative 6. On the right, I still have that 6x. And so finally, to isolate x, you can see 6 is being multiplied by x. So we want to do the opposite, divide by 6. And so on the left, we have negative 6 divided by 6, which is negative 1. And so that's less than or equal to x. In other words, x is greater than or equal to negative 1. So that's our final answer. That means that any number of any value for x that's greater than or equal to negative 1, like negative 1, negative 0.1, 0.5, etc., all of those values will satisfy this inequality, meaning that all those values of x, if you plug those in, the left side would be less than or equal to the right side. And here, it's a little number line, which you can kind of see, right? We have 0, negative 1. And so I colored in the dot from negative 1 and all the values to the right of it, right? In the positive direction, greater than or equal to negative 1. We color in the dot to signify that it could also be equal to negative 1.